In this lesson, we will study about the photoresistor, or light-dependent resistor, or LDR for short. A photoresistor is a semiconductor that changes its resistance value when exposed to light. The main purpose of a photoresistor is to convert light falling on its sensor area into an electrical signal. This signal can then be processed by an analog and digital logic circuit or a microcontroller-based circuit. To get a better understanding, let's take a quick look at how Arduino analog inputs work. Arduino supplies 5 volts to any module and then receives them back to the analog inputs. Depending on how many volts it got back, Arduino will know what state the module is in. The analog input shows a value from 0 to 1023. In order to understand the scheme that connects the photoresistor to Arduino, you need to understand how it works. To do this, imagine a simple scheme. Let's take an ordinary battery and an LED and connect them to each other through an LRD. As you can see, in the dark, the resistance of the photoresistor has a large value and the LED lights up dimly. However, when exposed to light, its resistance is significantly reduced and the LED will burn brightly. Now, let's try to connect the photoresistor to Arduino. If we connect 5 volts to the photoresistor and the second pin of the photoresistor to the analog input, we will get 5 volts no matter the state our sensor is in. To get any value though, we must connect a resistor. One pin goes to the analog input and the other pin to the GND. As a result, our resistor will take away some of the voltage, which will depend on its resistance. Thus, we will get the result in a certain range. Now, let's move on to practice. First, we connect the photoresistor to Arduino. For that, connect the two side contacts, one to 5V and the second to GND pins. The central contact is connected to the analog pin A0. Now let's connect the LED. We just have to connect pin number 10 and GND in module number 15. We put a resistor on pin number 10 to prevent burnout, and the GND is connected to the minus of the LED. Now open the Arduino program and write the commands. First, we need to declare an input pin. In our case, it is pin A0. We declare a contact for the LED and call it LED pin. The 10th pin is responsible for it. The next step is to set the LED pin mode to output, since by default, the pin works in input mode. Now we create a variable val to assign the value of the input contact. If val is less than 800, we give voltage to LED. Else, if val is greater than 800, turn off the LED. Excellent. Now the LED turns on and off when the room is dark or light enough, respectively. Thus, we got the concept of a simple night lamp. But if we make some changes to the code, we can make our lamp even smarter by making it change brightness more gradually depending on the surrounding light. So, as the room gets a little darker, the LED shines a little bit brighter. Or, if the room gets much darker, the LED shines much brighter. To make those changes, note that the Arduino output is from 0 to 255, while the analog output is from 0 to 1023. So we need to convert the value of the variable val using the map function. This map function proportionally transfers the value from the current range of values to the new range. In addition, remember that we want to achieve an inversely proportional relationship between the brightness of the environment and the LED. The map function allows us to do just that. So we are going to assign the new value to the LED level variable. We're going to convert val, set the current range from 750 to 900, and the new range from 255 to 0. Now stop and think about what we did. We have taken an input value, given it an original range, converted it inversely to another range, and assigned a new value to the output. So as the value of the photoresistor decreases, the brightness of the LED increases. Okay, but what do we do for values smaller than 750 or greater than 900? There is a function for this. This function is constrained. It takes a value and sets its minimum and maximum. So we give it the needed values, and val will not be higher than 900 or lower than 750. Now we can just type analog right to set the brightness of the LED, while setting LED pin to LED level. Let's run the code. The LED is initially turned off as expected, but as it gets darker, the LED gets brighter to full brightness when the sensor is in total darkness, and vice versa. So, brilliant! Now we have an adaptive nightlight. Congratulations! You have learned all the basic principles of the photoresistor and put them into practice.